Sorry about that. I start to record now. It's a good approach, okay? You use this approach a lot of time. You use, for example, if you have a cabling network, for example, to connect one place to other, you see this approach in the network ports, okay? It's easy to set up because you only need to connect, you need to have this equipment and connect the other device. It's more resilience, but has some disadvantage. One of them is this: if this guy broken, your network go down. Okay, you are completely dependent of this guy here. Okay. But again, it's a very nice approach. Okay, most of the common topology that you find in the in place, in local network, in order that. For example, here you have cable, no? But for example, one Wi-Fi, one in your home, you have the router provided from the ISP company. And this router is responsible for implement logically this approach. Okay? Because all the nodes need to transmit to the router and the router forward to the destination. Okay? Another approach is not so common today, but is okay, in particular in metropolitan area network, is the ring. The ring is, you have, again, you have a shared media, okay? And you organize this shared media like a ring. What it means? If you want to talk, did you see the competition that the people run and has a token, and you need to pass the token to the another runner? For example, for in the Olympic, you have this competition. Do you know what you're talking? Okay.
Yes.
It's like this competition. You have a token, and to talk, you need to have the token. And you use the token to send your package. When you finish the package, you return the token to the network. And the next guy get the token and start to make the conversation. In this type of medium, okay, only one guy talk for time. Okay, if you see this animation here, okay, I started, okay, give me a second. If you see, one guy get the token, and for example, the token is free, okay, it's running. Oh, know the way, start get the token, and start the transmission to node 2. Node 2, sorry, 1A to node 4. And you use the 1 to 2, 2 to 3 until arrive in the node 4. Okay? And in this approach, only one guy has the token. The advantage, the time to send is no. You know how many times you need to send a data, what is not due in the star and the bus. But you don't have collisions, okay? Because only one guy counts for time. Disadvantage is very slow. Today, you have a different approach to implement the ring in the very fast network like WiMAX, okay? But it's fast because the media supports a lot of data like fiber, okay? Any question about the ring? The next approach is the mesh. You see some technology in IoT that use the mesh. In the mesh, all nodes is connected with all nodes. It's a very difficult technology, but it's a very resilient technology. What means this symbol, Pedro? Did you understand or not?
Es que se ve muy enredado.
The mesh, again, I need to talk about this topic to understand what are you talking in ahead, okay? But again, if you lost some concept, we revisit this concept ahead. And when I revisit this concept, maybe it's making more sense to you. Okay. Don't worry if you lost some information. Okay. I hope and I believe at the end you can connect all the blocks. Okay. About the mesh topology, all nodes connect to all nodes. Okay. It's a very resilient network because in this approach, if you lost, for example, this node, for example, you think in this situation, A wants to talk if C, for example. A can send the data using this path, or A can use this path here, okay? Or use, for example, this path here and another path, because all the nodes is connected with all the nodes. What is the advantage? The advantage is if you lost, for example, this path here, you can use this one to send the data. It's very resilient, okay? It's very difficult to this network fail. But the problem is, one problem. Well, the first problem is, it's very hard to configure because you need to configure a lot of connections. The second problem is very expensive. This network is expensive because you need to have multiple connections. Okay, the routing protocol that you work here is a very complex protocol to implement, but it's a nice approach. For example, when you one good example. Think that you have three devices, okay? Device A, device B, and device C, okay? A and the coverage of A only see B, and C only see B, okay? B, C, and A, okay? If you have this situation, if you don't have a mesh topology, it's very hard, okay? Because if you lost this node here, you lost A and C stop to talk. But if you have another node here, and it is a mesh topology, you solve the problem. Did you understand the case? Did you understand why this approach is good?
Yes.
Okay. You already studied, for example, the Cisco technology, IoT technology. The Cisco IoT use a mesh topology. Okay, it's the idea of the Cisco. You have multiple devices that you can, for example, Cisco use. What's the name of the protocol? In IoT, a lot of you can use Wi-Fi, but you can use LoRa too in the Cisco device, and the LoRa use a mesh topology. Okay. Okay, another information. Okay, an IP address. What is IP address? IP address is a unique address that identifies the device on the internet. For example, your name is not a good, for example, Alexander. Alexander is not a good as a good approach to identifying in the world, okay, or at least in the Mexico. Alexandre de Barros Barreto is my complete name. It's not a good approach to identifying in the Mexico. You need another number. This number it can be a passport number or the RFC number, because in the RFC or the passport number, this number only one people have. Identifying. If I have a Mexican passport and I have the ID number of my passport, only this number is my number. Nobody has this same number. Okay? It's like the IP. The IP is a number that identify a node in a network. Only one node has this number. For example, here you have a smartphone that has a number. You have an IoT device that has another number. You have another IoT device that has another number. You have another IP or a tablet that has another number, and a computer that has another number. Okay? Again, the network course, you learn a lot. The 50% of the network course that you study next year is about the IP. Okay, give me a second, guys. Just a second. Oh, sorry. Did you understand what I believe? Who never listened before IP address? This term. It's the first time that you listen this term. I believe everybody already listen about, don't know exactly how it works, but already it's again, it's an address, okay? It's like again, it's like a RFC or like their passport number. Okay, so yeah, give me a second. Give me a second, please.
Okay.
Sorry, guys. So, any questions about the IP and about the information that I shared with you?
No por ahora.
Okay. So, now we start to talk about network mediums, okay? What is a network medium? It's links that connect nodes. If you see, until now, you didn't talk nothing about IoT, only about the network concept, no? The links that connect nodes define the speed, the security, and the size or the number of data that you can transport one place to other. One example of the network media is the wire-based medium, okay, like the UTP, okay, twist pair cable, okay. Again, you study this point in the network course and you can see the cable, okay, but it's a metallic cable that you use use electricity, you transport the data, and then electricity pulse to transport the data to one place to other. Use this type of cable. It's twist because the electricity generates electronic field around the cable, and this electronic field interferes in the data, or you can lose you can the one, for example, in this type of cable, you transform the data and send the data using this cable, okay? And what happened? The data that the pulse that you transport here interferes in the pulse of DIT, that interferes in DIT, interferes in DIT. To avoid this interference, you twist the cable, okay? What happens is the electron field, that the electromagnetic field that you generate here when transmit here annul this one annul this one annul this one, and this one annul, and so on. Okay, it's the main okay. It's the main. It's the how the twisting pair cabling works. Another cabling is the wire-based medium. It's a little different. You have a big copper cable, okay, but you have an isolator here, okay. And this isolator avoid that this cabling interfering in the another cable that you have close to it, okay. The advantage of this cabling and disadvantage of this cabling is this cabling is very flexible and you can transmit a large amount of data. This one is very protected. It's very difficult to broke, but you don't transmit a lot of data. Another one is the fiber optical cable. Okay, the fiber optical cable. You don't transmit electricity, but you pulse electricity pulse, but you transmit light, pulse of light. It's like it's a very thin cable, and you send the light here in a place, and the other side, the light is flow to the other place. The advantage of this system is you don't have the electromagnetic field to interference in this type of technology. The consequence, you transmit a lot of data, okay? A large amount of data. The problem is the fiber is a very thin, it's very easy to broke. You need to protect where you pass the fiber optical, the optical cable, okay? Again, you're learning about it in the network course. In IoT today, you will use the wireless medium, okay? You can have the cabling, yes, you can, but in the newest implementation of the IoT, all the implementation use the wireless, okay? And the wireless you use data transmission through the air. And you use or radio waves or microwave signals, okay? In the case of Milan, in the IoT network that you studied, we use radio waves, okay? It's easy to set up, but it's very difficult to secure. For example, if you transmit a data using your computer using Wi-Fi, if you don't use cryptography, the data, you can have a guy that listen your data and see what you transmit one to each other. The wireless has this problem. It's not exactly the same problem that you have in the cable. It's the collision. What is the collision? All the shared medium, like wireless, like wireless, you have the situation that two guys can transmit the data in the same time. Okay, when it happens, it's a collision. You lost the information. Okay, it's a problem that all the shared media has. So, any question to here, guys?
Not at the moment.
There is in the wireless there is a very specific type of network. Is the wireless sense network. Okay. The wireless sense network is a wireless network that has some characters. The first is a wireless connect smart object. Okay, we use to connect smart objects. But to create this type of network is a challenge because you have a diverse type of the device, okay? Different type of device, different type of the protocol of the device. It's a very heterogeneous. For example, you can have a smartphone from Samsung and a device from Apple, for example. And it is resource constrained. Remember that you told you that this type of network is very complicated because you don't have a lot of resource. Okay, you need to reduce the consume of the power. The wireless sensor network limitation. Limited process power. Its impact, for example, you cannot have very complicated protocols, need to be light protocols. Limit memory, you cannot store a lot of information. Lost communication. The protocol of this type of network need to consider that sometimes you lost the communication and you need to reset the network. Limit transmission speed. You don't have a lot of big bandwidth to transmit data, and limit power, as we already told. This type of network is a little different than the Wi-Fi, for example, because it's an event drive. What is event drive? Something needs to happen in the sensor to transmit. For example, you have a temperature device, not temperature, for example, you have one sensor that measures if your door is open or closed, and you only transmit when you change the status. For example, the door is closed. When the door is open, you change the status, you transmit the information. Okay, it's an event drive. Another one is like a temperature sensor. Okay, you transmit in a specific frequency. Okay, for example, you transmit each second, you transmit the current temperature of the device. Did you understand the two cases? Any questions? No questions?
No questions.
When you analyze the different type of technology, one thing that you need to analyze is the range. What is the range that you're looking for? Your device is very far or is close? If it's very, very close, you need a WPN, okay? A personal area network. For example, Bluetooth solve your problem. But if the device is more than 2 meters, is for example, 100 meters, you need a different technology like Wi-Fi. But is the another device is a 10 kilometers, 20 kilometers, you need a different technology. The range of that you need to acquire define the technology that you use. Okay, again, here you have Bluetooth, here you have Wi-Fi, and so on. And the frequency that you use, including Wi-Fi. Wi-Fi, you have two frequencies, 5 gigahertz and 2.4 gigahertz. If you want to use the 5 gigahertz, you have better links with more quality, more data rate, but in opposite, the range is a little smaller. If you want to transmit a little far, you need to use 2.4 gigahertz. Did you understand?
Yes.
Again, the range define, for example, the technology that you can use. For example, is a short range, you use Bluetooth. Is a mid range, you can use the Zigbee, you can use the WiMAX, You can use PLC or you can use Wi-Fi. It's a long range. You need to use the 5G, 4G, 3G, or 2G. Okay? Only consider the wireless, okay? For example, the Bluetooth. If the maximum distance between the two devices is 10 meters, you can use the Bluetooth, the IEEE 802.15.1. But if you need to transmit the range is 100 or 10 to 100 meters, you need to use or Wi-Fi or ZigBee, 6LoWPAN, and others. But if you need to transmit for a long range distance, you need to have a 5G, 4G LTE and others like 6.4 or lower. Okay, it's another technology. As I told you, one question that you need to define is, do you need a license frequency or not? The license frequency is the frequency that is regulated to the ITU or the FCC, and you need to buy to use this frequency, okay? You need to have the authorization to use this frequency. An unlicensed frequency, you don't need, like Wi-Fi. The ITU defines an unlicensed spectrum for industry, scientific, and medical ISN portion of the radio bands. Okay, the unlicensed means that you don't have any guarantee or protection that to use this band. Okay, you use, but you don't have any guarantee that your application works. Okay, the ISN band is 2.4, is the frequency of the Bluetooth, and any other standard from 802.15. One example that when you use the problem that you can have use unlicensed frequency. When the Wi-Fi start the Wi-Fi 802.11G, okay, the G standard support indoor and outdoor, okay. When you start to have this standard, a lot of companies start to install this system to provide connections around the one campus, like the Technology Monterey. I remember one place that you have a lot of industry, okay, it's like a neighborhood of industry, and all of the industry start to install the Wi-Fi G to transmit data to one place to integrate your network. What happened? What happened? That one installation interfere in the another company. One company start to produce problem to another company that produces a problem to another company. What happens is all the network does not the networks do not work because you have a lot of noise. One network generates noise to another. And the problem is the equipment? No. The problem is your neighbor? No. The problem is an unlicensed network. It's a licensed frequency. You cannot assure nothing. It's like you buy a car, but you didn't, for example, you buy a car, a used car from the internet and receive the car in your home, but you already pay, okay? Maybe the car is good, maybe the car is bad. It's the problem of the unlicensed frequency. You cannot, 80% of the time it's work, but there are situations that is not work and you cannot do nothing. Did you understand the problem to use unlicensed frequency?
See.
Okay. Another question that you need to think is about the power consumption. The power node has a direct connection to a power source. If you if you have a very advanced process, you consume a lot of power, okay? And how you generate energy to your system? The most of the IoT device you use battery, okay? Few on one use, for example, the solar panels and others technology, renewable technology, but a lot of them use batteries. And the batteries is a problem because the batteries has the amount you need to recharge the batteries in a period. Okay, if you use a very advanced or very powerful computer to IoT, you need to recharge the battery a lot of times, like your smartphone. If you have a smartphone, like I have, for example, Samsung, I believe it's S7 or S8, I don't know, S12, I cannot remember the number. But if you have the newest iPhone, and you use the iPhone all the time to send data, maybe the battery is finished in 10 hours. In 10 hours, you need to recharge the battery. It's the question that, for example, my smartwatch, if I recharge my smartwatch today, maybe I need to recharge in 2 or 3 days ahead because it's not a very powerful computer. It's a very simple computer. It's a simple operation that you wish to perform here. It's different than my smartwatch. Sorry, my smartphone. It's the reason that this network is a constrained network, okay? Because you have low power, in other words, battery power constraints, and you have lost network. Sometimes you don't have a full connection, like a mesh connection. And the topology of the network change all the time because the nodes move in the place. For example, the car network. The car network is a very constrained node network because the car changed the time. The topology changed the time. And you need the protocols that this type of device has, need to handle the situation, need to design the topology all the time, need to learn the topology all the time, okay? So some examples of the technology. For local area network, first is a short range communication. A short range of communication. You have the rate of the goal of this network is around 40%. Is well established standards, okay, and you use inside the buildings. Problems: battery life, provision, and network course independence. For example, Bluetooth and Wi-Fi. You have another type of network, is the low power wide area, LP1, is the network of the Internet of Things. It has low power consumption, low cost, and position. The problem: you don't have a high data rate and is an emergency standard. What is the problem of the emergency standards? It's very difficult to interoperate. For example, if you use the technology from one provider, maybe this provider don't work with another provider. Okay. One example of this technology is the LoRa. It starts late. And finally, you have the cellular network. Traditional use to M2M. Okay. The good things: existing coverage. Okay, you have coverage in the world. For example, you don't need to install a new infrastructure. You have a high data rate, but the problem is the autonomy and the total cost of ownership. It's very expensive. For example, the 4G, LTE, or 5G is very expensive to create this network. Any question, guys?
For
So,
now.
I will give a break. It's for our last interval, okay? And we'll start to teach about the IoT access technology. If I didn't finish this point, this topic today, I will finalize next week, okay? Don't worry about it. But you'll start today, okay? Any questions till now, guys?
No.
Okay. Okay, I give a break, 12-minute break. We will return 00, okay? See you soon, guys.